How are you all? Today we are here to learn a concept, a very interesting concept, mole concept. This mole concept, most of us, and even including me, used to think that it's a very tough concept because it has a lot of calculation. But today I'm here to make this concept easy to understand. So let us learn this. So before learning what is mole concept, we need to understand the three terms. Those terms are first one, relative atomic mass. Second one, relative molecular mass. And the last one is a relative formula mass. I hope all of you are very much familiar with these words. So let me come to this. What is relative atomic mass? It is nothing but mass of one atom. For example, mass of one atom of hydrogen, which is equal to 1. Mass of one atom of carbon, which is equal to 12. So that is nothing but the mass of relative atomic mass, which is nothing but mass of one atom. Then coming to the relative molecular mass. So relative molecular mass is nothing but the mass of one molecule. But here you need to understand, molecules are formed only with the covalent compounds. So we write the relative molecular mass for the covalent compounds which has the mass of one molecule. For example, carbon dioxide, CO2, it's a molecule of covalent compound. So mass of one carbon dioxide, which is equal to 44. So same way, the relative formula mass is also mass of one molecule, though it is usually related to ionic compounds. You have to remember here, formula mass will be used for ionic compound because in ionic compounds you don't find the molecule. So that's why we use relative formula mass. For example, mass of NaCl. So it has one sodium, which is 23 mass, and one chlorine, which is 35.5. So add up to form 58.5. Now let us calculate the relative formula mass or the relative molecular mass of the following compounds. So first we need to understand which one comes under relative formula mass and relative molecular mass. As I told you already that relative formula mass will be used for ionic compounds and relative molecular mass will be used for covalent compounds. So how to identify whether it is ionic compound or covalent compound? So we need to understand that ionic compounds are formed by the electrostatic force of attraction between two oppositely charged ions. So these two oppositely charged ions are formed by metals and the non-metals. So the basic thing is to understand here whether they are for ionic compounds or covalent compounds. You just need to understand whether they are made up of metals and non-metals or only non-metals. So if they are made up of metals and non-metals, then they come under the ionic compound, for which we will write relative formula mass. And if they are made up of only non-metals, so then that means they come under the covalent compounds, which is nothing but the relative molecular mass. So let us understand that first. So here the first compound what we have is potassium hydroxide, KOH. So potassium is a metal and hydroxide, which is hydrogen and oxygen, non-metal. So metal non-metal ionic compound. So for this we will calculate the relative formula mass. Then for calcium nitrate, so calcium is a metal, nitrogen and oxygen are non-metal. So again metal and non-metal. So that means for this also we calculate relative formula mass. I am writing a short form RFM, is nothing but the relative formula mass here. So coming to the third one, nitrogen dioxide. So it is made up of nitrogen, which is a non-metal, and oxygen, which is also a non-metal. So this nitrogen and oxygen, they are covalent compounds. So covalent compounds, for that we will write relative molecular mass, which is nothing but RMM. Then the last one, carbon, hydrogen and oxygen. So this compound is ethanol, which is made up of carbon, hydrogen, oxygen. So all three are non-metal. So again we calculate the RMM, that is relative molecular mass for this also. Okay. So I hope you understood that for ionic compounds we calculate the relative formula mass, and for the covalent compounds we calculate the relative molecular mass. Okay. There is no much difference. Both are same. Only the thing is the name we have given for ionic compound relative formula mass, and for covalent compounds relative molecular mass. Okay. Okay. So now to calculate the relative formula mass or relative molecular mass, we need to have a periodic table with us. So periodic table will help us to find out what is the mass of these elements. Okay. So now let us calculate. So now when I look into this formula, I see there is one potassium. So I have to multiply the mass of one potassium. When I look into the periodic table, I find out that the mass of one potassium is 39. Then I have to add plus, I have one oxygen, and one oxygen I multiply with its mass, and the mass given in the periodic table of oxygen is 16. Then again I will plus, and I have one hydrogen, and each hydrogen has the mass of 1 unit. So now I have to calculate this, add up, multiply all this and add up. So 39 times 1 is 39, 16 times 1 is 16, and 1 times 1 is 1. So 39 plus 16, which is 55, and plus 1, which is 56. So that means the relative formula mass of potassium hydroxide is 56 units, which can be written as later. Now let us calculate the formula mass of calcium nitrate. So first we have to find out how many calciums are there. There is only one calcium, so I will multiply with the mass of calcium, which is given in the periodic table, is 40. Plus, so I have to understand here, this 2 belongs to N as well as O3. So that means I have 2 nitrogens here. So 2 times the mass of nitrogen is 14, plus 2 times 3, which is 6 oxygen. So I have total 6 oxygen, and each oxygen mass is 16. So now when I calculate the total, it is equal to 164. So the formula, the relative formula mass of calcium nitrate is 164. So likewise we can calculate the mass of these two compounds also. So let us calculate nitrogen dioxide. As you see here, there is one nitrogen, and each nitrogen has the mass of 14, plus there are 2 oxygen, and each oxygen has the mass of 16. So now is 46. So now the last one I will give you as a chance to calculate. So calculate the mass of ethanol, that is, it has 2 carbon, 6 hydrogens and 1 oxygen, and let me know in the comments, so what is the mass of ethanol. Now let us understand what is mole. So mole is the unit of amount of substances. So here you have to understand that each mole has a unit in it. So the unit of mole is considered as MOL, and each mole of any substance. So if you take 1 mole of any substance, it can be hydrogen, oxygen, can be a compound, it can be an ionic compound or covalent compound, will have 6.02 into 10 to the power 23 particles in it. Okay, I'll repeat here. the unit of mole is mol, and 1 mole of any substance. So this substance can be anything, but each substance will have 6.02 into 10 to the power 23 particles in it. So this 6.02 to 10 to the power 23 particles, a number is given by a scientist called Amedeo Avogadro, and this number is called as the Avogadro's constant. Avogadro's constant. Okay, kindly remember this number. 6.02 into 10 to the power 23 is called as the Avogadro constant, and this one helps us to find out how many particles are present in each mole of any substance. Okay, now let us understand what is 1 mole of any substance. So if you take 1 mole of calcium, which is equal to 40 grams of calcium. So that means 40 grams is the relative atomic mass of calcium. So if you look into the periodic table, you will find out that each calcium weighs around 40 units, which can be converted into 40 grams. So 40 grams of calcium will have 1 mole of calcium. And you know that 1 mole of any substance will have how many particles in it? So that means it will have 6.02 into 10 to the power 23 atoms of calcium. Okay. So now let's take one more example. 1 mole of hydrogen, and hydrogen here it's a molecule, it's H2, it is not just Ca, it's H2. So that means the mass of each hydrogen is 1, but there are 2 hydrogens, so that means 2 grams of hydrogen will have 1 mole of hydrogen, which is equal to 1 mole of hydrogen. And again, so 2 grams of hydrogen will also have 6.02 into 10 to the power 23 molecules of hydrogen in it. I hope you are understanding. So here we are calculating the number of atoms. Here we are calculating the number of molecules. So you need to understand that, and whenever you are taking the molecule, you have to take the whole mass of the molecule. So that means each hydrogen molecule has 2 grams. If you take 1 hydrogen, it becomes 1 gram. And 1 gram of H is not equal to 1 mole of H2. So it has to be 2 grams of hydrogen in it. So likewise, calcium atoms. So 40 grams of calcium will have 6.02 into 10 to the power 23 atoms, which is equal to 1 mole of calcium. So now let me take one more example here. So 1 mole of, let us take water. You know water, the formula is H2O. Again, it's a molecule. So this molecule of water will have the total mass. So there are 2 hydrogen and 1 oxygen. The mass of 1 oxygen is 16, 2 hydrogen is 2, so 16 plus 2, 18. So that means total 18 grams of water is equal to have 6.02 into 10 to the power 23 particles in it. So that means you need to understand here, the 1 mole of any substance will be equal to its either a relative atomic mass, a relative molecular mass, or relative formula mass. And each relative atomic mass, formula mass, or the molecular mass will have the same number of particles, which is nothing but we call it as Avogadro's constant. Okay. So now to calculate the number of moles or the number of particles, we can use a simple formula. Let's call number of moles equals number of particles over Avogadro's constant. So to calculate this or to remember this formula, we can use a simple triangle. So in this triangle, on the top we will keep number of particles, below we will keep number of moles. N means number of moles, small n, and the Avogadro's, which is nothing but the 6.02 into 10 to the power 23. So now to calculate the number of moles, we use this formula. So at the same time, if you want to calculate the number of particles, so what we use if you want to calculate number of particles, so we just multiply moles with the Avogadro's constant. So this becomes number of moles times the Avogadro's constant. Using this formula, let us calculate some problems so that we can understand this easily. The question is, how many moles of neon contains 1 into 10 to the power 23 neon atoms? So here they are telling to calculate the number of moles, and they have given the number of neon atoms. So kindly understand here, this particles, when we say number of particles, so these particles can be atoms, can be molecules, and can be ions also. So depending on what they have called, we have to calculate. So here in this question they have given the number of atoms, so we are going to write it as number of atoms instead of number of particles in the formula. So now the question here is to calculate the moles. So when we have to calculate the moles, the formula becomes moles, that is small n, equals to number of particles, or here in this case the neon atoms, over the Avogadro's constant, which is 6.02 into 10 to the power 23. So now we have, it is already given that there are 1 times 10 to the power 23 atoms, number of atoms are present in neon atoms, and over the Avogadro's constant, which is 6.02 into 10 to the power 23. So now you have to use calculate this. So I will get the answer as 0.166 mole. So that means in 1 into 10 to the power 23 neon atoms, so the number of moles present in it are 0.166 mole. Okay, so now let us take one more question. Okay, so now I have one more question here. What is the number of hydrogen atoms? So that means we have to calculate the number of hydrogen atoms in 3 moles of hydrogen gas. So they have given 3 moles and it is in hydrogen gas, and we have to calculate the number of hydrogen atoms. So the formula which we are going to use is number of particles. So we change the number of particles to number of hydrogen atoms. Number of hydrogen atoms equals moles times the Avogadro's constants, that is 6.02 into 10 to. So need to solve this, we need to understand that there are 3 moles of hydrogen gas. So it says it is not each hydrogen atom has 3 moles here. Here it's the hydrogen gas which has 3 moles. So each hydrogen gas will have 2 hydrogen atoms. So that means when we write hydrogen gas, we write it as H2. So that means each hydrogen will have 2 hydrogen atoms. So these 2 hydrogen atoms will having 3 moles. So that means totally it will have 6 moles in it. So total moles are present as 6. So now here we will not write just 3. So you will write 2 times 3, which is nothing but the 6. So now to calculate the number of atoms, so number of atoms or hydrogen atoms equals 6 times 6.02 into 10 to the power 23. So now you multiply the 0.612 into 10 to the power hydrogen atoms. So that means 3 moles of hydrogen gas will have 3.612 into 10 to the power 24 hydrogen atoms. I hope it is clear for you.